This video we are talking about how to solve 1D Poisson equation with final element method. Okay, so we are taking the Poisson equation minus d square u by dx square equal to 2. X is lies between open interval 0 to 1 and the boundary conditions are given u of 0 equal to 0, u prime of 1 is 0. So what is that? So our domain is, this is our domain 0 to 1. We are making n points, so we take it, this is x0, this is x6, x5, x4, x3, x2 and x1, and equally step size. So we are following the equal step size. So the length of the two guys is always h is the fixed. So then our discretizing, our domain is 0 to 1 into 5 equally spaced elements. So these are the elements e1, e2, e3, e4 and e5. So equally placed. So we know that equally spaced, this is 0 means this is 0 0.2, 0 0.4, 0 0.6, 0 0.8 and 1. So this is, we take it as x5, this is our x0, we define such a way that. Okay, first we are going to apply the linear basis function. Now I take the linear basis function as n0, ni of x and n0 of x and ni of x. So that is x1 minus x divided by h, because I choose the equally spaced. Ni of x is x minus xi minus 1 divided by h whenever x is lies between xi minus 1 to xi. This is for interior nodes. For interior nodes, the basis function for interior nodes, n0 and nn are boundary nodes. So these are n1 and n1s are boundary nodes. For boundary nodes, okay, so we are going to how to see the basis function. This is n0, this is n5. You look, so support of all ni's are, support of ni's are is nothing but xi minus 1 to xi plus 1. So these are the support. Support means what? Where there is a function largest open set or non-zero. So this is the support of ni's. Now we define the, first we go for the weak formation. So we are given the d square minus d square u by dx equal to 2 and we choose, now we multiply the test function 5. So here u is a trial solution and phi is the test function. Okay, we multiply and integrate over the domain. Domain is 0 to 1. So we apply the integrals by parts formula. We will get it as, so d square u by dx square times 5. This guy is, sorry, here this is equal to, this is plus, this is minus becomes. So whenever you will get it as, you will apply the boundary condition, we will get the weak form is, this is our weak formation, correct? These are the weak formation by the suitable test function. I am taking the boundary of phi of x0 is 0 and phi of 1 also 0. Such a way that I choose it means I will get such. Now, from the Rayleigh's theory, u can be written in the form of I equal to 0 to 5 alpha I times ni of x. Here ni of x is the basis function. We already defined that the previous slides, correct? We define in such a way that, correct? These are the ni's. So I start from 0 to 5. Totally 6 basis function will be there. Now I apply. Now I will choose test function is nj of x. What will happen? That is our next step. Suppose alpha I equal to alpha I times, I will take apply here. Here alpha is simply a constant. We have to find. So our aim is how to find the stiffness. So now you already assume that support of phi a is nothing but xi minus 1 to xi plus 1. Okay, so this is the guy. Then I will take it as what will come, d phi I divided by dx times d phi j divided by dx. This is our first term, correct? Whenever I equal to j, then what will come? So that is I equal to j. So that times our k, I will define what will come, d phi I divided by dx the whole square. This guy is equal to, this is the guy will come. So what will say d phi I by dx equal to, we automatically will get it as minus 1 over h times will come whenever I is x is lies between xi minus 1 to xi to xi plus 1 1 over h whenever x is lies between x to xi, okay, 0 otherwise, correct? This is the way. So whenever whenever I equal to j, we always get it as 1 over h square. So this is d phi I by dx the whole square. We will always get 1 over h square. Next step, what I want to take it as, suppose I is not equal to j and I equal to j plus 1 or I equal to j minus 1. Okay, so whenever I is or I equal to j plus 1, in this case what will happen is d phi I by dx times d phi I minus 1, we take it here, j minus 1, sorry, I minus 1 divided by dx. What will come, d phi I by dx, you will get it as minus 1 over h square whenever xi minus 2 x I, okay, 0 otherwise, correct? Because support of phi a is phi I minus 1 to support of phi I is xi minus 1 to xi plus 1. Support of phi I minus 1 is xi minus 2 to xi only. So only these both has the common support is, so support of phi I times phi I minus 1 is nothing but, so common of both. So intersection of these two sets, what will come, that is nothing but xi minus 1 to xi. So this only will get it. Okay, similarly d phi I divided by dx times d phi I plus 1 divided by dx, you will get it as minus 1 over h square. Here the only variance is xi to, so we want to find d phi I divided by dx times d phi I plus 1 divided by dx is nothing, you will get it as minus 1 over h square whenever xi, this common support is xi to xi plus 1, 0 otherwise. Because the reason is support of phi a is xi minus 2 xi plus 1. Support of ia plus 1 is xi 2 xi plus 2. So the common support is xi 2 xi plus 1. So that is why our guys are, you will get it as in each element. So ki you will get it as 1 minus 1 minus 1 1 divided by h square, but will come, but we want to take the integrator over xi to xi, so we will get it as h. So you will get it as 1 over h. The reason is, suppose I know that support of I is, so this guy is, I can return and summation I equal to 0 to 5 integral over xi minus 1 to xi plus 1 alpha times d ni of x divided by dx times d nj of x dx. We can write these both guys are equal. So whenever I want to take the integrate xi to xi to xi, when we start from x, this is we start with xi plus 1. Now this is my integrate, I will take it, means automatically I will get it is, suppose I will take, these are the constant, I will take the outside, because this is I get minus 1 over h square or 1 over h square. So then simply constant, the length become h only. So that is why it become, your k is become 1 minus 1 1. Now this is I will get it correct. Sorry, this is 6 nodes, 5 elements. So that's, now I want to assemble, how I can assemble the matrix, that is the my aim. Okay, now so I think everyone is clear with how this stiffness, this local stiffness matrix is forming. Now each element, suppose the first element, so my each, basically I have, this is x naught, this is x naught, this is x1, this is x2, x3, x4, x5. This is e1, e2, e3, e4, e5. So I will take it as first element is, the global matrix are defined by such a way that first e1 what will come is, that is our k1. So the matrix is 1 minus 1. So we take the 1 over h outside, 1 minus 1 1, remaining all are 0. So totally this is become 6 by 6 matrix. This is first element. Okay, first element I will got it, this is the matrix. Second is e2, so this is for element e1 or e1. So plus again 1 over h, e2 what will come, e2 is the first element is become, you will get it as, this is element is, first element is become 0, this guy is minus, this guy is also 0, this guy is become, this guy become 1 minus 1 minus 1 1, remaining all are 0. This is for element 2. So element 3, now you can easily visualize, element 3 is automatically plus 1 over h. So it starts from the third row. So these elements are 0, 0, 0, 0, 0. This guy is also 0, 0, 0, 0, 0. Third element is here we start 1, minus 1, minus 1, 1. Remaining are of 0. This is for elements. So 6 by 6 matrix you will get it. This is for element 3. So finally you will get it. So if you are going to again, then you add it all the matrix, that is global stiffness matrix, you will get it as 1, minus 1, 0, 0, 0, 0, minus 1, you will get it is here 2, minus 1, 0, 0, 0. Here you will get it as 0, minus 1, 2, minus 1, 0, 0, 0, 0, minus 1, 2, minus 1, 0, 0, 0, 0, minus 1, 2, minus 1. You will get 0, 0, 0, minus 1, 2. Sorry, not 2. Here you will get it the 1 only you will get it. So this is your finally the stiffness matrix. You look here, this is guy is always become tridiagonal matrix. Correct? Because only the main diagonals are and the super diagonal and the subdiagonals are non-entries. So this is our global stiffness matrix div times 1 over h. So 1 over h will be the, I forget to mention it. So 1 over h is common. If it is the h is become not uniform, it will be here will place here. Okay, fine. This is the global stiffness matrix. Once you are finding the global stiffness matrix, you can easily solve by this equation by any LU decomposition method or CG method, or so many softwares also available how to solve the linear system. So you have any problem or any comments, please come to post in the comment section. Thank you for watching this video.